Welcome to our session this afternoon. My name is Temba Nube. This is your Physical Sciences live broadcast session that is proudly brought to you by Pagama Research and Development in collaboration with the Free State Department of Education. So today in our Physical Sciences session, we shall be focusing our attention on the parts that are particularly on the knowledge area of mechanics. So the mechanics is by far, your section that carries the most marks in your Physical Sciences paper 1, with a special focus on the physics, right? So we are saying that what are these topics that are in mechanics, but today we'll focus on the Newton's laws, vertical projectile motion, linear momentum, and impulse, those three. So to complete the entire knowledge of mechanics, we also need to incorporate or also focus our attention on work, energy, and power, which is often, in my opinion, one of the easiest topics if you really understand the basics or the fundamentals. So today we'll only focus on Newton's laws, vertical projectile motion, as well as linear momentum and impulse. So that's what we're going to do today. So our session will take a form because this is entirely revision. So I'll call upon you to try and follow the discussions in our live broadcast, but also if given an opportunity, which is something that I'm definitely going to do, I'll give you a couple of minutes, say 5 minutes, to attempt a particular problem. Then I'll ask you to stop. Once you stop, then we do the feedback so that we can try and correct where we might have possibly gone wrong, with an intention to adequately prepare ourselves for the exam. That's not going to only elevate our confidence, but it will also make us, better understand the concept, because not only are we going to focus on the feedback in terms of the questions that we would have sampled to use as part of our practice for the purpose of this revision, but also we'll focus our attention on the techniques in terms of the examination. Right, without much further ado, let's look at the layout. This is a reminder, we've been through this multiple times before, to say it's a 3-hour paper that consists of 2 sections. The section A, which is the multiple choice. The multiple choice carries a weight of 20 marks. So the 20 marks are questions from all the topics. Now the multiple choice assesses or examines or tests your understanding of all the topics that are in paper 1, right? These topics are your mechanics, which is your linear momentum, VPM, your Newton's laws, and work, energy, and power, and then wave, sound, and light, which is focusing on the Doppler effect. And then we've got electricity and magnetism, that has got 3 subsections. Number 1, it's your electrostatics, your Coulomb's law, electric field, and electric field at a point, right? And then we also have electric circuits, as well as your electrodynamics, which includes electrical machines, as well as your alternating current. And then last but not least is photoelectric effect, which is under matter and materials. Right, now the section B assesses all these topics as they are listed. So it's 130. When you add that to the 20, it gives you 150. So for every 50 marks, you are allocated an amount of a time that is equivalent to an hour. So if you've got 150 marks, that translates to 3 hours. So within the 3 hours, if you really know what you are doing, there's no time to sleep within the 3 hours. However, also start with the questions that you are most comfortable with, or those particular questions where during the reading time you'd have picked up that you can, collect the maximum marks. Very, very important, right? And then if we can go ahead now, what are the quick wins? These are the questions or the topics that you're most likely going to get the most marks, right? Now, if you look at it, it says here the definitions, the examination guidelines of 2021, It's the only document that we are allowed to use. And remember, a guide is supposed to be used to prepare you for the exam. So when do you say you are adequately prepared? So you are going to use the exam guide as your checklist to determine whether you are able to answer the questions that might potentially come, right? So every long section, section B, has got a remembering type of a question, which we call it basic recall. Okay, so to recall is to remember. Now, it's either you know or you don't. It's either you remember or you don't. It's either you recall or you don't. These are your straightforward type of questions that you must be able to collect the marks. And then we've got the formula sheet, very, very important. It will say, for argument's sake, Fnet, right, is equals to MA. This is a typical example. Now, this can assist me to remember what the Newton's second law says. When a net force acts on an object, the object will accelerate. The acceleration is directly proportional to the net force and inversely proportional to the mass. So these mathematical equations, they are of importance to us in terms of assisting us to remember what these concepts are or the definitions. Hence, we would refer to them as our low-hanging fruits or our easy-to-get marks, which we might as well think of as our quick wins, right? So always start with the questions where you can get the most marks. Then the question, therefore, that may follow is, how then do I determine I'm able to get the maximum marks in question 3 instead of question 5, for argument's sake, right? Think of it this way. We've got the 10 minutes reading time between 8:50 and 0900 hours because we start the exam at 9 and it ends 3 hours later, that is at 1200 hours, right? So in the last 10 minutes of the reading time, you're not writing, you go through the paper, you're scanning through, you look at scenarios that might be familiar to you, you look at the definitions that you can still remember. And if you see that I'm really comfortable with this one, then once the invigilator says start writing, you may start. Those are the questions that you start with. Why is that important? It also assists us in terms of managing our time. So if we can collect the maximum possible marks as early as possible, then we give ourselves a decent amount of time to try and attempt those questions that might be potentially challenging for us. So that's the whole technique around starting with questions that you can accumulate the most marks, right? And then remember, once again, you either get 0 out of 2 if you don't remember the definition, or you get the full marks 2 out of 2, right? Okay, so do not leave the multiple choice blank. Okay, now we'll use a practical example of a multiple choice to speak to the technique that you might as well use in terms of managing the multiple choice. Because if you want to get a distinction, you need to get a minimum of 16 out of 20 in both paper 1 and paper 2. So if you do your calculations, it kind of betters your opportunities of getting a good mark. So worst circumstances, you must not leave the multiple choice unanswered, because options are given. If you can eliminate, then you can choose from 2 that are left after elimination. So the 2 distractors, now that they are out of the way, we are able to choose from 2, and instead of leaving it blank, we've got a 50% chance of getting it correct, right? So include all the keywords in the definition. Ensure that you use these keywords in the correct context. Okay, I'll explain what that means. Okay, so the examiner is very particular when it comes to definition. Not only are you going to include the keywords, but also the keywords must be used in the correct context. What does exactly that mean? It means that when I read your definition, it should convey the correct scientific meaning or sense to the examiner. That's what it says. Okay, like in the practical example of the Newton's second law, there must be a net force somewhere. Okay, because what causes the acceleration is a net force. Okay, now if you say the acceleration is directly proportional to the net force. It simply means that the magnitude of the net force affects the size of the acceleration of the object concerned, right? But if you swap the two and say the net force is directly proportional to the acceleration, what you are implying is that the acceleration causes the net force, yet it's the net force that causes the object to accelerate. So the key words, net force and acceleration, they are both present, but they've not been used in the correct scientific context. That's exactly what I mean. So capture the key words, and when you write down the definition, when you read it, it must convey the correct scientific meaning. That's what it means. Right. Let's look at the first law of Newton's first law of motion. Right. Now, we've been seeing this, but I think it's also equally important for us to try and make sense and have what we refer to as conceptual understanding of the Newton's first law, right? What exactly does it mean to us? How do we recognize that this scenario is about the Newton's first law? Okay, that's our focus. So our discussion today will take a different form. I want you to put on your thinking caps so that by the end of this session, given a scenario, you are able to say, yes, this is about first law, this is not about the first law, and whatnot. Right. Now, the first law talks about the state of motion. Right. Remember, the effect of a force, any force, be it a force, applied force, frictional force, applied force, any force can change the state of motion of an object. That's what it means. So what is important with the first law is that we must recognize, or we must be able to identify that there is a zero net force acting on an object. So F net acting on an object is equal to 0 newtons. Now, does it mean that there are no forces acting on the object? Definitely not. Let's take, for example, this car that is driving, right? So if you look at the car, there is the car. It's a free body diagram that we want to draw. So it's a free body diagram. It's a diagram that's free of the body. So in place of drawing the car, we'll put a dot to represent the car. Okay? Now, what do we have? We've got the driving force. This driving force, let's call it the applied force of the engine on the car. So the engine exerts a force on the car to propel the car forward, right? That's the force of the engine on the car. That's the forward force, right? And then the car is moving on a horizontal rough surface, right? Because there is kinetic frictional force, right? So there's a kinetic frictional force, F kinetic. Also, there's the force exerted on the car by the center of the earth, which is the force of gravity, right? So the center of the earth is pulling the car towards itself according to the universal gravitation. So there is a force exerted by the center of the earth on the car towards the center of the earth, which explains why the weight of the car acts downwards always, right? And then we've got this applied force, which is a contact force exerted by the surface on the car perpendicular to the surface, which is the normal force. Now, in this scenario, the net force is 0. Then the question is, when a zero net force acts on the object, does it necessarily mean there are no forces? Definitely not. The forces are there, but the sum or the resultant or the net or the total of the forces is equal to 0 newtons. So in the event that there is a 0 newton net force acting on an object, the object will either be stationary or move at a constant velocity. Okay, so in both cases, when an object is moving at constant velocity, we must know that F net is equal to 0 newtons. So in other words, if we say F applied plus F kinetic is equal to 0, this is correct. Okay, either way, it also shows that F applied is equal to minus F kinetic. Now, what does this tell us? It tells us that the applied force of the engine is equal in magnitude to the kinetic frictional force exerted by the surface on the car in the opposite direction of motion. Hence, these two forces, they cancel each out in that way. then we get a 0 Newton force. Similarly, we also agree that Fg plus normal is equals to 0. That's the net, plus is the net. Fg is equals to negative n. It means that the minus in this case suggests the direction of the force. So the normal force acts in the opposite direction of the force of gravity. So which explains why this car will move at a constant velocity, or essentially remain at rest, right? So wherever there is a object moving at constant velocity, so in a scenario, watch out for the examiner writing constant speed, constant velocity in uppercase or in capital letters. The moment you see that, just highlight the constant velocity. The moment you see rest, just highlight that, because the science behind an object that is at rest or an object that's moving at constant velocity is actually saying to us, look, there is a 0 net force acting on the object. I hope it makes sense. Right. So that's the first law. Let's go to the second. Also, what is important with the first law that I need to go back, we talk about an object. It says an object will remain at rest. How many objects is that? It's one. Similarly, if we go to the Newton's second law, it talks about a single object as well. Okay? Now, what's so different about the Newton's second law is that there is a non-zero net force. Loosely put, it will say when a net force. So when we talk about a net force, therefore its magnitude cannot be 0, right? So in other words, we are saying F net is not equal to 0 newtons. So the net force is non-zero, unlike in the first law. So the distinction or the difference between the first law and the second law is this force, net force. First law, 0 net force. Second law, non-zero net force. Now what happens when a non-zero net force acts on the object? Now that we understand that when there is a 0 net force, the object will either maintain its position or remain stationary or stay at rest or move at a constant velocity. Now, what will happen if there is a non-zero net force? The object is going to accelerate. So the acceleration of an object is a consequence of the net force acting on it, or is a result of the net force acting on the object. So in other words, we are saying, when we sing the Newton's second law, when a net force acts on the object will accelerate. For me, that's by far the most important part of understanding what the Newton's second law is all about. It says, when a net force acts on an object, the object will accelerate. So there is a cause effect. The cause is the net force. The effect is the acceleration. So if I may ask a question to say, what causes the object to accelerate? It's the net force. And this net force must be non-zero, right? So the acceleration is directly proportional to the net force and inversely proportional to mass. Now, what does it mean? In this case, let's say the car is what? 500 kgs. Okay, the car is 500 kgs. And then the truck is double the mass, which is 1,000 kg, which is 1 ton. Okay. Now the same net force acts on these two objects. So F net in this case is equals to 5 plus minus 3, which is 2 newtons to the right. Okay. Similarly, on that, F net is equals to 2 newtons to the right. So the same net force acts on both objects. We agree that because in both cases there is a non-zero net force, therefore there will be an acceleration in both cases. But now if we were to compare between the car and the truck as to which one is going to accelerate more, the car is going to accelerate more because of the mass. So the smaller the mass, the greater the acceleration, provided the same net force acts on them, which is the case. It's the 2 newtons to the right and 2 newtons to the right for both the car and retract. So the same net force will produce a greater acceleration for an object with a smaller mass. That's what it means. Okay, so if we were to sketch the graph of F net in newtons versus acceleration in meters per second squared. Okay, so these two are directly proportional. You increase the net force, it will produce a greater acceleration. And then for mass in kgs versus it's the acceleration in meters per second squared, because it's the response variable, and then mass, then we have got that curve, right? Take note of that. So that's our Newton's second law. And then the Newton's third law talks about two objects or two bodies, unlike the first law and the second law, right? Now, in this case, two objects are involved, okay? Both objects exert a force on each other simultaneously. This means, much as we would want to think of it as an action-reaction force, it's more like action-action, because it happens at the same time. That's what we mean when we say these two forces, they act simultaneously. So we are saying force by body, this is body B, and then the guy is body A. Force by A on B is equals to force by B on A in the opposite direction. So the minus suggests the opposite direction. But also there's something that is important here. If A exerts a force on B, it means that the change in momentum of B will be equals to the change in momentum of A in the opposite direction, right? Why is it in the opposite direction? Because force by A on B is in the opposite direction of force by B on A, right? So this is Newton's third law in a nutshell, right? Because of this action-reaction. While A exerts a force, this is the force, actually this is the force by on B, this is force by A on B, and then this one is the force by B on A. Okay, whichever the case. But these two are equal in magnitude and opposite in direction, right? Okay, and then the other very important Newton's law, which we studied in grade 11, and we are required to have a clear understanding and demonstrate that we can apply it under different circumstances or scenarios that we might be confronted with. Okay, it's important that we also recognize that the universal gravitation also involves two objects. Okay, so the Earth, for argument's sake, is object A, and then the moon is object B, right? So the gravitational force, this is the gravitational force that we're talking about, is actually the force that each one of these exerts on each other. So if I'm going to draw a free body diagram of A, object A, which is the Earth, the force of attraction on the Earth by the moon is towards the moon. This is the force by B on A, right? And then again, if I look at the moon, which is object B, okay, the force on the moon is exerted by the Earth on the moon towards the center of the Earth. So this is force by A on B, right? Now, if you look at these two forces, force by B on A is equal in magnitude but opposite in direction to the force by A on B, right? So if you come to think of it, the universal gravitation talks about the masses. So if, for argument's sake, we look at this is the product of the masses, M1, M2. This is kg squared. Okay, that's what we mean by product of the masses. And then this is the gravitational force, in newtons. You increase the mass, the product of the masses, also the magnitude of the gravitational force will increase. Very, very important. Right. So take note, these are the masses. R is distance between the centers. So in other words, this is the radius of the Earth that we use. So the other distance is actually from the surface of the Earth to the center of the other object B. So take note of that. So the aspect that speaks to between the centers is very, very important. Okay, so this is the square of the distance. Square of the distance between the centers. Right. Okay. So that's as far as the universal gravitation. Right. Now, let's look at a typical example of a multiple choice question, and also, speak to the technique that becomes very, very important when you approach a typical multiple choice question. So we say there's 10 of them. These questions, they are not necessarily of the same level of demand in terms of what you have to do to get to the correct option, So take note, you need to give it a decent amount of time so that you are able to respond correctly, right? So it says here, a ball is projected vertically upwards, right? I'm going to underline that. So if a ball is projected vertically upwards, this ball is a projectile, okay? So this means that the ball is a projectile, okay? Take note of what we are doing in terms of the technique. The ball is indeed a projectile. Then the follow-up question is, what is a projectile, right? This is an object that is given an initial velocity and then moves under the influence of gravitational force only, right? Okay, where do we get the part of gravitational force only? Okay, it's projected vertically from the ground and reaches its maximum height after a while. It says here, ignore effects of air friction. This means that this object is in free fall. Okay, what does that mean? If we were to draw the free body diagram of a free falling object, we will draw that dot and then we've got Fg, right? So the only force acting on this object is the force of gravity. Hence, this is a typical example of a projectile that is in free fall. Why are we saying it is in free fall? This is the type of motion in which the only force acting on the object is the force of gravity, as it is shown on this free body diagram. So if we were to draw a free body diagram of a free falling body, it will be 1 mark. Why 1 mark per se? Because there is only one force acting on the object. Right. How will the acceleration, take note, acceleration is written in capital, and the total mechanical energy of the ball at its maximum height compare to that immediately after it was projected? Now, this is a typical example of a closed system. Okay, why are we saying this is a closed system? The total net force acting on this object is 0. Okay, the net for external forces is 0. There are no external forces acting on this object. Now, if an object is in free fall, number one, it undergoes constant acceleration. Constant acceleration. Constant acceleration is typical example of what we call uniform acceleration. Okay. Now, this object is in uniform acceleration. What does that mean? It means that the velocity of this object changes by the same amount per unit time, and therefore the rate of change of velocity of this object, delta v over delta t, is equals to 9.8 meters per second over 1 second downwards. What does that mean? It means in 1 second this object will change its velocity by 9.8 meters per second going downward. So if it is projected upward, it means it will slow down, because once it slows down going upwards, it means it's accelerating downwards. That's what we know. Why does it accelerate downwards? Because the net force, according to Newton's second law, is acting downwards. So the direction of Fg is the direction of the net force, which explains why the object experiences a constant acceleration in the direction of Fg, which is downward. So acceleration at the highest position will always be equal to, okay? Because we're comparing from the point of projection until it reaches the maximum position. So it is launched from there to there. Let's say it's launched from position A and then reaches the highest position, which is position B. So during the motion from A to B or B to A, the acceleration will be equal at any point because it undergoes uniform acceleration. So now we'll eliminate B and we'll eliminate D. Why? Because acceleration remains constant. So the acceleration of the ball will be equal at A and also will be equal to the acceleration at B. Now we've eliminated option B and option D. Now this is free-falling body. As this object slows down, the kinetic energy of the ball is converted to gravitational potential energy, okay? Because we know that E mech of the ball, okay, at A is equals to E mech of the ball at B. In other words, in a closed system, okay, the total mechanical energy remains constant. So the answer is equal to, then we get option A, right? That's the correct answer. I hope you understand the technique. So this is not your typical straightforward question that you can just take a wild guess. You need to interrogate the question, the problem statement, highlight the keywords, ask yourself the critical questions. What does it mean when it says the ball is projected, then we ignore effects of air friction? What does it mean when we say the ball is undergoing uniform acceleration? Right. So that's one practical example. Right. Now, this is a very important concept map or the mind map when it comes to the Newton's laws. Let's recap on that. The key thing about first law is that in terms of the state of the motion of the object concerned, the object is either stationary or at rest or moving at constant velocity, meaning that the object experiences a zero net force. Done. So after all has been said and done, in as far as the first law, these are the key things that you need to always remember, right? And then Newton's second, there is a non-zero net force acting on the object, right? Okay, so the net force causes the object to accelerate, right? And we also know that the same net force acting on the object is equal to the rate of change of momentum. Now, this is our Newton's second law in terms of linear momentum. You know, the net force acting on the object is equal to the rate of change of momentum. Okay, and then the Newton's third law talks about two bodies. Force that body A exerts on body B is equal in magnitude to the force exerted by body B on object A in the opposite direction. So the minus suggests opposite direction. This can be in a typical example of a collision or an explosion. So the scenario that we dealt with before we looked at the concept map, where the boy jumps off the boat, okay, so the boy is exploding from the boat. It's not a collision. So while the boy leaps off the boat, he exerts a force on the boat. Simultaneously, or at the same time, the boat exerts a force on the boy in the opposite direction, which causes them to have a change in momentum in the opposite direction. Right. So this explains the Newton second law in terms of how it links to the third law. Right. Now, let's look at also the formula sheet. Very, very important tool. You need to familiarize yourself with the data sheet. Okay. Why is the data sheet of particular interest to us? because there are routine calculations. If we talk about a routine calculation, let me maybe let's take time to talk about this because it's very, very important. So a routine calculation is your usual calculation. Calculate the net force. Then it's 3 marks. Okay. Right. The 3 marks, number 1 is for copying the formula correct. Okay. Number 2 is for substitution. Right. Number 3 is for calculating using the calculator the correct answer, and the correct answer must include the correct unit. So if a question says determine or calculate, so the key word is calculate, and then immediately after that you pay attention to the mark allocation. It does give an indication of how much has to be done. Say for argument's sake, in electrostatics the question is 7 marks. It says calculate the net electric field point at P due to charge A and B, 7 marks. That's a multi-step question. So you will always get a routine calculation, that's 3 marks. Always take into account that you have to, for the formula, you refer to the data sheet. Very, very important. So if it's about the first law, you write F net is equals to 0 newtons. It's not in the data sheet because it's through your demonstration of understanding that the net force indeed is 0 newton when the object is stationary or when the object is moving at a constant speed or constant velocity in a straight line. Okay, so you copy the correct formula, you substitute, and then you get the correct answer, right? And then include the correct unit. Sometimes there will be another 1 mark which says calculate the velocity or calculate the acceleration. Obviously you must include the direction. So this one of direction will carry an extra mark because direction is a component of the vector, or a vector has got both magnitude, which is the answer including the correct unit, as well as the direction, right? And take note, this formula, do not confuse it with F electrostatic is equals to K Q1 Q2 over R squared. Okay, this is the Coulomb's law. This is the Coulomb's law. It talks about charges. Okay, the other one talks about what? Masses, which is the universal gravitation law. So you must know your data sheet in and out, right? Okay, moving forward. Okay, so in terms of the Newton's law in application, the following are very important. You must identify the forces correctly that act on the object. Please be able to distinguish between a free body diagram and a force diagram. Okay, this is a typical example of a force diagram. There is the object, there is a pulling force there, and then there is the normal force exerted by the surface, and then there is the force exerted by the center of the earth, and then there is the kinetic frictional force. This is a force diagram. Okay, and then also underline the keywords rough surface to indicate that there is kinetic frictional force. Smooth surface is frictionless, so don't include the kinetic friction or the frictional force, be it static, if the surface is smooth. Okay, whenever an object is hanging like that, let's say on the ceiling, you can't talk about the normal force. Why? Because this object is not resting on the surface, right? So for questions involving calculation, if it's a routine calculation, 3 marks. We have indicated that. If it's a vector, pay attention to the direction. And then if it's 4, 5, 6, 7, 8 marks, know that it's a multi-step calculation and you need to show all your calculations as clearly as you can. Right. Okay, this is what I'm going to do. I will give you 5 minutes to try this question, because the most marks I think are on 2.3.1. I'll give you 5 minutes to attempt this question, and then we'll do feedback. After the feedback, we'll take a short break, and then after the short break, we'll continue with vertical projectile motion. So your 5 minutes starts now. Welcome back, grade 12. May I ask you to stop after attempting the few questions? Then we may take a discussion now so that we are able to rectify where we might have potentially gone wrong. So you can mark your own work at this point in time. Right, now let's go over the problem statement. It says crate P of mass 1,25 is connected to another crate Q of mass 2 kg by light inextensible string. Light inextensible. It means the mass of the string is not going to be taken into consideration. The only masses that we're going to consider is the mass of P, which is 1,25 kilograms, and mass of Q, which is equal to 2 kilograms. Right. The two crates are based on a rough horizontal surface. What does that tell us? There is a kinetic frictional force acting on both objects, right? Then there is force F of magnitude 7.5 newtons acting at an angle theta to the horizontal, which is applied on crate Q as shown in the diagram. The crate accelerates, very, very important, at 0,1 meters per second squared to the right. This is a very, very important statement. I'm going to highlight that. Now, what does this tell us? If the crate accelerates, it means there is a non-zero net force acting on the system, and the non-zero net force acts to the right. According to Newton's second law, the direction of the net force is the direction of acceleration, right? So it comes as no surprise when the first question says, state Newton's second law of motion in words. So this is essentially about Newton's second law. So this is Newton's second law. All right. Now, the first question says, state Newton's second law of motion in words. Pay attention to the marks. It's 2 marks. Okay. So what does the Newton's second law say? It says when a non-zero net force acts on an object, the object will accelerate in the direction of the net force. This acceleration is directly proportional to the net force and inversely proportional to the mass. Done. So the other version of it, the net force acting on an object is equal to the rate of change of momentum. Okay, so both are acceptable, but sometimes the examiner might say, prescribe and say, state Newton's second law in terms of linear momentum. Okay, right. And then now draw a free body diagram for crate P. So here is our crate P, right? It's a free body diagram. What is pulling crate P? Is the tension there, right? And then it's on a rough surface. There it is. There is kinetic frictional force. Okay. There is also the weight, which is Fg, and then there is also the normal force, which is N. Now pay attention to the mark allocation. It's 4 marks. It means there are 4 forces. 1, 2, 3, 4. Okay. So the mark allocation is also an indication of the number of forces that are acting on that particular object. Right. And then calculation. Calculate the magnitude of tension in the string. 4 marks. Right. Here is the part where we are supposed to calculate. So this is about Newton's second law. Right. F net is equals to ma. 1 mark for copying that formula. Now, this is for object P, for body P, right? So the net force is in terms of the horizontal forces acting on object P, right? So the horizontal forces in this case is force T and force F kinetic, right? So we are saying it's going to be T plus F kinetic is equals to ma, right? Why are we saying plus? Plus is the net. But also, let us not forget that the kinetic frictional force acts in the opposite direction of the tension. But there is a part that where we must go back and say Crate P experiences a force of what? 1,8 newtons. Okay, we're interested in crate P, right? So it's gonna be tension. We need the tension. That's the question. We must calculate the tension on the string. Okay, then this goes on to say T is equals to, or T minus 1,8 is equals to mass. The mass in this case is 1,25, right? 1,25. So it's 1,25. We're also given the acceleration. Okay, the acceleration is given as 0,1 meters per second squared, right? 0,1, right? So that's our substitution then. Okay, so this entire substitution has to be correct. So then we can go to our calculator and say T is equals to, okay, 1,25 times 0,1, that gives us 0,125. Okay, 0,125 plus 1,8. We've transposed the 1.8 to that side, so this is plus 1,8, right, which is the magnitude of that force, right? So, and then T is equals to 1,925 newtons, right? Now here it says the magnitude, so the direction is not important in this case, right? So always round this off to the next 2 decimal places, right? So even if you write 1,93, is still correct. Okay, so in this case we've got the formula, the whole substitution, the substitution on the left, the substitution on the right, okay, and then the correct answer, which includes the correct SI unit, and then this gives you a total of 4 marks. Right, having said that, we shall take a short breather for 5 minutes. Then when we come back, we shall focus our attention on vertical projectile motion. See you after the break. So now 5 minutes break to ayokugcina ke 5 minutes. Angithi lapho besayenza umsebenzi. Yeah. Yeah. Siko. Sharp. Go on. What is this thing that you said? No, I was invited by Sibanye Stillwater. Welcome back, Grade 12, from our short ad break. We are continuing with our session. We're still focusing on the mechanics. We've chanced down the feedback on the Newton's laws application, a very, very simple calculation from past papers. And I think the main thing that one has to emphasize on is the fact that we are trying to go over the technique that is important when you attempt these type of questions. Without any further ado, let's move on to the next focus area, which is the vertical projectile motion. Right, now VPM is, we will shorten it, okay? VPM for vertical projectile motion. Key is ignore air friction. The moment you see the statement ignore friction, we just need to understand that the object is in free fall, and during free fall the only force acting on the object is the force of gravity. Right, now, and if the gravitational force acts vertically downwards, it means the acceleration will also be downwards in the direction of Fg. And then we also agreed that the object experiences a constant acceleration, which is 9.8 meters per second squared. What does that mean? It means the acceleration is the rate of change of velocity. It means the change in velocity is 9.8 meters per second every unit of time, which is equal to 1 second. Right. Okay. Now, what are the key definitions in as far as VPM? It's free fall. This is motion in which the only force acting on the object is the force of gravity. Okay. Okay, it's not gravity, it's force of gravity. And then projectile is an object, okay, that is given an initial velocity. And moves under the influence of gravitational force only. Okay, these are two very, very important definitions in as far as projectile motion is concerned, right? Now, having said that, I'm sure you do realize that in the definition of projectile, there is free fall, okay? Now, what is important is that a projectile can either be launched upwards or downwards. In both cases, what is important is that the object is given a non-zero initial velocity. So if you drop an object and it moves under the influence of gravitational force only, yes, the object is in free fall, but it's definitely not a projectile. Why is it not a projectile? Because it's not given an initial velocity, right? So if we project an object downwards and launch it, it becomes a projectile. Let's say the initial velocity is 10 meters per second. It means after 1 second, the velocity will be 19.8 meters per second. What does that mean? It means that from its initial velocity, 1 second later, the rate of change of velocity is constant. It means it's 9.8 meters per second in 1 second. If maybe I can try and put it in that way, right? So this is what is important with projectile. Only the force of gravity acts on the object. Number two, in free fall, the object experiences a constant acceleration in both magnitude as well as direction. Right. Okay. Now in VPM, read the scenario carefully. Very, very important. Understand the problem statement. Don't assume you've seen this before. Okay? Because in so doing, you might potentially throw yourself under the bus by missing what could be essentially a catch in that particular problem statement. Right. So also draw a trajectory. A trajectory is the path that an object is following. Say, for argument's sake, an object is launched from the edge of a roof, goes up, and then comes to the ground. This is an example of a trajectory. It helps us to better understand the motion of the object, and it also allows us to consider motion in any case between 2 points, initial position and final position. Why is this important? Because we're dealing with vectors in this case, right? Okay, and then always choose the direction. One would write take upwards as positive, whatever the case. It doesn't have to be, but by so doing, because we're dealing with vectors, we know that position is a vector, change of position, which is displacement, is a vector, rate of change of position, velocity, is a vector, rate of change of velocity, which is acceleration, is also a vector. The only quantity that is not a vector is time, in as far as the equations of motion. The examiner might ask you to find the height, but for you to find the height, you must use the vectors. So the equation of motion are vectors. So pay attention also to the data sheet. Okay? Now, we've got a scenario here. I'm going to give you 6 minutes to try this one. So try and go as far as you possibly can. Maybe to assist you, it says here a ball is thrown vertically upwards, from the top of a building, okay, which is 25 meters high, with a velocity of what? 12 meters per second. Okay, then on its way down, the ball passes the door, which is a height of 1.9 meters. There is the height of the door, right? That's 1.9. Okay, and then ignore effects of air friction. That's very, very important. So I'm going to give you 6 minutes to try until 3.2.3, and then we'll do some quick feedback on that. Pay attention to the techniques and the approach that we discussed in the previous slide. Your 6 minutes starts from now. welcome back, grade 12, to our feedback session. We've just looked into the vertical projectile motion problem. Now I'll ask you to put your pens down and try to follow the discussion in as far as the feedback is concerned. Right, so the first question says, define the term free fall, right? So we've defined free fall in the previous slide, where we said that free fall is the motion in which, or the type of motion in which the only force acting on the object is the force of gravity, right? Or the gravitational force. That is also allowed. So that's going to be 2 marks. Why? Because it's a definition. So the key word is motion, the only force acting, force of gravity. So I want force of gravity, and the word only is very, very important. Now, it says here, calculate the time taken for the ball to reach its maximum height. Right. Now, so I'm going to draw a trajectory, right? There is the edge, right? There it is, okay. And then this is position A. It's thrown up and then goes all the way down. So this is position B, right? So I'll take upwards as positive, okay? Take upwards as positive, right? Meaning I'll consider the motion, okay, from A to B, okay? Meaning A is the initial position and then B is the final position, right? Now, what do I know? I know that the initial velocity of the ball is 12 meters per second. Why is it positive? Because it's launched upward. So if this ball is launched at a velocity of 12 meters per second, it means it is indeed a projectile that would experience free fall. And then now the acceleration of this ball is minus 9.8 meters per second squared. Why is it so? Because the motion of the ball initially is upwards, and we took upwards as positive, meaning the acceleration of the ball is always downwards. It will take the opposite sign. That's why it's minus. Now at the highest position, a position B, the ball will stop, okay? That's why it's 0 meters per second. And then now the first question says, calculate the time, okay, taken by the ball to reach its maximum height. So that is 3 marks. So from the 3 marks, what do we know? We know that is the formula, which is Vf is equals to Vi plus A delta T. That's 1 mark for that. So the final velocity is 0. The initial velocity is plus 12 plus negative 9.8, okay, delta T. So we're looking for delta T, okay? So if we transpose the 9.8 negative, is going to be positive. Then we'll get delta T is equals to 12 divided by 9.8. So the time that it takes the ball to reach the highest position, if we go to our calculator, is 12 divided by 9.8. This gives us 1.22, 2 decimal places, 1.22 seconds. Right. So the 3 marks is your formula, your substitution. So the direction of initial velocity is opposite to that of acceleration, because the ball is launched upwards and its direction of acceleration is downward. And then the correct answer, including the second, which is the SI unit, that gives us a total of 3 marks. So you can mark your own work from that point, right? And then moving along, we want to, the follow-up question, calculate the velocity with which the ball strikes the ground. Very important question. So we know from position A until the ground, the direction is downwards. So it means from this position all the way downwards, this is the initial position, this is the final position. The change of position of the ball is minus 25 meters. Why? Because it's downward. So we want the velocity with which it strikes the ground, right? So we don't have the time that it takes for the ball to strike the ground. So we want VF, so we'll use VF squared is equals to VI squared plus 2A delta Y. So the final velocity is what we're looking for. Our initial is 12 positive squared plus 2 negative 9,8 negative 25, right? Okay, so VF squared is equals to, we go to the calculator, 12 squared, right? If you multiply negative 9.8 and negative 25, it will give you positive. So it's going to be plus 2 times 9,8 times 25. Okay, this gives us 634. Okay, 634, right? So VF, if you calculate the square root of that, okay, it's 5, we need to calculate the square root of 634. Okay, square root 634. Okay, right. So this changes to 25. This is 25,18 meters per second. Now, if we go back to the question, it says calculate the velocity. So velocity has got magnitude and direction. That's why this is 4 marks. So if we go back to that, this is going to be, in which direction is it moving? It's moving downwards. Okay, so downwards is the direction. So 1 mark for the formula, for the substitution, for the magnitude, for the direction. This gives us the 4 marks. All right, and then we can go back to that last question, which says the time it took the ball to move from the top of the door to the ground. So this is the top of the door, this is the ground. Then the direction of change is that way, right? Change of position. So what that simply means is that in terms of our data, we have got the final velocity, which is equals to 25,18. Okay, so final velocity 25,18 meters per second. This is negative. Why? Because it's downwards, right? The change in position is also negative 1,9 meters. So we want the time, okay? The time, the acceleration we've got. So if we want the time given this, we are, first of all, this is 4 marks, okay? From the top of the door to the ground. We can find the time, okay? If we can, and then after that, we can find, we can find the initial velocity, and then from the initial velocity, we can find the time. So there are many ways to do it in these 4 marks, okay? So first things first, we know the acceleration, we know the change in y, we know the final velocity. We only need the time, okay? So the formula that we can use in this case is from the equations of motion, we can find the v initial, okay? Because the v final we've got is equals to v initial, okay, plus a delta t, right? Right. Now the challenge here with this equation is that neither do we have the time as well as the initial velocity, so we can't use that. If we go to vf squared, okay, is equals to vi squared plus 2a delta y, then we are able to find the initial velocity at the edge of the door, right? So that works out to, okay, vf squared, okay, which is vf squared is equals to vi squared plus 2a delta y. So the vf squared is 25.18, okay, negative, okay, is equals to vi squared plus 2 times negative 9,8 multiplied by negative 1,9, which is the height of the door downwards, right? So our VI squared is equals to, if we go to our calculator, we will have 25.18 squared, right? Minus, why is it minus? If we multiply negative 9.8 and negative 1,9, it's going to give us a plus. If we transpose the plus, it's going to be minus. So it's going to be 2 times 9,8 times 1 times 1,9, right? This gives us 596, that, okay, alpha, and then we want the square root of that value, okay, which is 24. So the initial velocity is 24,43 meters per second, right? So this is downwards, right? Now if we want the time, then we can say V final is equals to V initial plus A delta t. So the final velocity is negative 25,18 is equals to negative, because it's downwards, 24,43 when it reaches the edge of the door, okay, minus 9,8, okay, delta t. So if you transpose the 25, the negative 24 is going to be positive, so it's going to be 25.18 less 24,43, and then we divide this by 9,8. Okay, so our time is 0,08 seconds. 0,08 seconds. So in other words, it takes the ball 0,08 seconds to move from the edge of the roof, from the top edge of the door until it strikes the ground. Right. Okay. This is a very interesting question. This is a typical example of a multi-step type of a problem. Right. And then last but not least, because of time constraints, we will try together to draw the graph of time of the velocity versus time from the ball from the moment that it is thrown upwards until it strikes the ground. So we shall use the ground as the frame of reference. So our heading is V versus T, right? Okay, there we go. And then on the horizontal axis, we've got time in seconds. And then on the vertical axis, we've got velocity in meters per second. Right. Now, what must we show? We must show the velocity with which the ball was thrown upwards. We were told that the initial velocity of the ball when it was launched from the edge is 12 meters per second upwards. That's why it's positive. Okay. And then the ball slows down uniformly and comes to rest. This is 0. The initial is positive 12. Okay. Then time taken for the ball to reach the maximum position. This is where the ball was. This is at the time when the ball was at the highest position. So the velocity decreased from 12 to 0 in how many seconds? We can go back to our calculations to look at the time. The time is 1,22 seconds. So this is 1,22. And then after that, the ball continued to accelerate downwards. Now it was moving downwards. Now the velocity with which the ball strikes the what? The ground. So when the ball strikes the ground, that's the final velocity of negative 25, let's just verify the value. This is 25,18. There it is. Okay, this is negative 25,18. So that's our velocity versus time graph for the motion of the ball. So the 3 marks in this case is for showing the 12, for showing the correct time, and for showing the correct final velocity when it strikes the ground. Remember, the direction of velocity when it strikes the ground is opposite to the direction of its initial velocity when it was launched vertically upwards as a projectile. Now, having said that, I think you do pick up a sense that the questions on vertical projectile motion, much as they are often challenging, it's a question of how you break it down to try and understand each aspect of the question in a manner that you are able to collect all the marks, or the maximum possible marks, if I may say. Because by the end of this session, I think we can also appreciate that if the examiner doesn't ask you to define a projectile or to state whether the object is a projectile or not, and thereafter you have to justify as to why you think it's a projectile or it's not a projectile. Actually, that it basically goes back to the fact that you have to know what a projectile is. So it's either freeform or projectile. You must know those definitions. Secondly, the routine calculation, define the direction. Take upwards as positive or downwards as positive, whatever the case may be. Then thereafter, pay attention to the vectors. Very, very important. With that said, this is a very crucial time of our last push. We will also be meeting each other on the 7th and on the 8th for our last push programs for just in time. On Thursday, the 7th, we'll be looking at paper 1 because the National Senior Certificate exam is on the 8th, which is a Friday, where you'll be doing the physics. And then on the Friday, we are doing the chemistry after you have written the paper 1. So when we do the revision, we are not going to focus more on mechanics now. We'll look at the rest of the topics. I hope this session was indeed, of benefit to you. For myself, Themba Ncube, and cheers and bye-bye for now.